Hi, so we have this Regents prep with the Mathster domain and range. June 2014, question 1. Officials in a town use a function C, so C is the function, to analyze traffic patterns. Cn represents the rate of traffic through an intersection, where n is the number of observed vehicles in a specified time interval. What would be the most appropriate domain? So domain are the x values, range are the y values. So we're looking for the x values, and we know the function Cn is equal to something in terms of n. So maybe there's a box here, maybe even back here, right? And this is the number of vehicles. So number of vehicles, and this is the rate of traffic. So this would represent the range. This blue part is the range. And the domain is the number of vehicles. So which would be the most appropriate domain for the vehicles? Could you have negative numbers for vehicles? No. So 1 and 2 are out, right? Because it contains negative number of cars. What about half and 1.5? Even that won't work. So all of these are out. What's the only choice we can use? Answer 4. So you could have 0 cars, you could have 1 car, 2 car, 3 car, and so on that are passing the intersection. Hence, answer choice 4. So answer these questions using logic. If you see something that doesn't apply, you wouldn't put that in. All right, so we have this question. Let fx be let f be a function such that fx is equal to 2x minus 4, and it is defined on the domain 2 till 6. The range of this function is, that's what we are trying to find out, the range. Okay, so we know the domain is the x values, so we have the x values, right? We are looking for the range, which is the y values, and the function is 2x minus 4. So we've got all this information, so let's plug it in. So fx is 2x minus 4. You've got x and fx. And let's put all these guys in. 2, 3, 4, 5, 6. And let's plug it in here. So in place of the 6. So 2 times 2 minus 4. So that's 4 minus 4. 2 times 2 minus 4. That's 0. Then 2 times 3 minus 4 is 2. 2 times 4 minus 4 is 4. 2 times 5 minus 4 is 6. 2 times 6 minus 4 is 8. So now we have these values right here, 0 till 8. So what's our range? So it's starting from 0 and it's going on till 8. So answer choice 1. All right, so we have this next question. The function ht is equal to negative 16t squared plus 144 represents the height, ht, in feet, of an object from the ground at t seconds after it is dropped. A realistic domain for this function is, so we are looking for the domain. Domain is the set of x values, right? And x is time. What are the possibilities for time? Can we have negative time? We cannot have negative time, right? Can we have 0 till 3? Yes, we can. But can we have beyond 3 seconds? So even this is wrong. So we don't need the height. This, if the question was range, then this would be the solution. but we will go for all real values because the time can be anything. So we have this question, the graph of the function fx is equal to square root of x plus 4 is shown below. The domain of the function is, and we have 4 choices. So let's look at the graph. Where is it starting from? It starts from this point, right? So let's put in this point, 0, -1, -2, -3, -4. It starts from -4 and is going beyond -4 and it's going on. So it keeps going wherever till infinity. So it starts from -4 and it goes up. So the domain will be x is greater than or equal to -4, which is right here. Answer choice 4. All right, we have this question, August 2015, question 1. A toy rocket is launched from the ground straight upward. The height of the rocket above the ground in feet is given by the equation ht is equal to -16t squared plus 64t, where t is the time in seconds. Determine the domain. Domain is x values. Range is y values. We need the domain. So what are the x values? So the values of t, this is the x value. This is the y values. So this would be range ht and t would be your domain. Okay, so seconds, time in seconds. What is the existence of seconds? So we can have t is greater than or equal to 0, right? For seconds, so time can be 0. Time can be 1, 2, it can be 3.5, it can be 5.75, and stuff like that, right? So we can say t is greater than 0 because the domain is related to time, which will only take positive values. All right, so we have this question. The range of the function defined as y is equal to 5 exponent x. So now we are looking for range. Range is the y values. Domain is x values. So we've got this, right? So let's draw this graph. So here I drew the graph. The asymptote is right here, right? Where the graph does not intersect this line. It's not cutting it. So I'll remove the line just to show you. So if you expanded this on your graph, you'll notice that it does not cut the y-axis. Does not intersect. Sorry, does not intersect the x-axis. Does not intersect the x-axis, which is right here. So if you were to look at your graph, it's more or less like this. It's above the x-axis, right? But it keeps going on for forever on the y-axis. So what are the values of y over here? You've got 0 right here, then you have positive 5, 10, 15, and so on. So are these all positive values? They are. Hence we'll choose choice number 2. Anything greater than 0 is your range. So the range of the function fx is equal to x squared plus 2x minus 8 is all real numbers. so the choices are less than or equal to -9, greater than or equal to -9, less than or equal to -1, greater than or equal to -1. So I drew the graph on Desmos. And what is our point? So we've got negative, this is our y-axis, right? We are looking for the range, which applies to the y-axis. So this point right here is with the -9. And then you've got -5, 0, 5, 10, 15, and so on. So what's your range? Anything that is equal to -9 or greater than -9. So let's merge these two things, right? Let's merge these two conditions. So we get y is greater than or equal to -9. Y greater than or equal to -9. Where do we see this? Answer choice 2. Morgan throws the ball up into the air. The height of the ball above the ground in feet is modeled by the function ht is equal to -16t squared plus 24t, where t represents the time, every time in seconds since the ball was thrown. What is the appropriate domain? So you see a pattern, right? So what are the possibilities for the domain? So we need domain. Domain is the time. Now anything with the time will apply. So there's this, and then there's this, right? So now we've got, you're throwing the ball into the air. So there are these two possibilities. So just check which ones apply, and then we'll figure it out. So I attached the graph. So where are these points of intersection? There's 0 and there's 1.5. So let's look at the choice which has this in there, 0 and 1.5. Beyond 1.5, it's going to go in the negative, so that wouldn't apply. So it's like throwing the ball. You start the time, when does it come back to the ground? In this case, it comes back in 1.5 seconds. So it's answer choice 1. All right, so here we have what is the domain of the relationship shown below. So the domain is the x values. So let's look at those x values, and let's see which one has all these choices. So there's +4, there's +1, and there's 0. So 0, 1, and 4. Answer choice 1. Okay, so we are given this question: if the domain of the function, so the x values are given to us of this function 2x squared minus 8 is -2, 3, and 5. This is the domain. These are the x values. What are we looking for? We are looking for the range. So what I did was I plotted the graph. So let me attach that right here. So here's the graph, right? We want the y values. So what are our y values for this section? So there's 0, right? We've got this point. Then at 3, let's put in 3 over here. It's not showing in my graph, but if I put 3 here, I'd get 2 times 3 squared minus 8. This is f3, right? So f3 would be 2 times 9 minus 8, which gives me a 10, right? And then if I put in 5, I'll get 2 times 5 squared minus 8. So that's 2 times 25, which is 50, minus 8, which gives me 42. Sorry, 50 minus 8. So I've got 50 minus 8, which just 42. So what are my values? I've got 10, I've got 42, and at -2 I've got 0. So look for these values: 0, 10, and 42. Answer choice 3. So we have this question: if fx is equal to x squared plus 2, which interval describes the range? So we're looking for the range. Range is the y values. So I plotted the graph. Let's put that in here. So we've got this graph. Now let's look at the y values. They start from 2, from right here. 2 is our value, our starting value, and it's going on till infinity. So it includes 2, but it goes on till infinity. So answer choice 3. 2 is included, and infinity, which you cannot, it's not a value, it's not a value in itself, it's a large value, but we don't know what it is. So that is not, you can never reach infinity. So therefore answer choice 3. Alright, so we have this: at an ice cream shop, the profit PC is modeled by the function PC is equal to 0.87c, where c represents the number of ice cream cones sold. An appropriate domain. So domain is the x-axis. So that is the number of ice cream cones sold. So now think about it. Can you sell one ice cream? Can you sell two? Can you sell five? Can you sell 100? Yes. Can you sell 150.5? No. So all of these are acceptable. So you want an integer. Can you sell negative ice creams? No. So it's anything above 0. You need a positive integer. That's what you're looking for. So answer choice 2. So this one is relatively easy. If the function fx is equal to x squared and the domain, which is the x values, is 0, 1, 4, 9, what is its range? These are the y values. So I would just plug all these in here, put in x. So make a table 0, 1, 4, 9, and find fx. So what's 0 squared? 0. 1 squared is 1. 4 squared is 16. 9 squared is 81. Look for these values. Look for these guys. Where do you find it? Answer choice 2. So we have this question: the function fx is equal to 2x squared plus 6x minus 12 when it has a domain consisting of the integers -2 to 1. So those are our x values, -2 to 1. And we are trying to find out the range. So you can put in all these values: -1, 0. So what I did was I went to Desmos and I plotted the graph. So this is what I have right here. And I got the table for it. So I figured out the values using the table. So I've got this set. Now let's see what the values are. At -12, at -2 it's -16, at -1 it's back to -16, at 0 it's -12, and at 1 it's -4. So let's look at these in our range values. So we have -16, then we have -12 and -4. So that's right here. Answer choice 2. So I have this question: which interval represents the range? Range is your y values of the function hx is equal to 2x squared minus 2x minus 4. So again, I plotted the graph. One easy way is always to plot the graph and see what the shape is. and then use that to determine your answer. So what's our least value? In this graph, we notice that the least value is right here, 4.5, right, with the negative. So negative 4.5 is our least value on the y-axis, right? And then we see that the graph is going up till infinity. So let's look for this, that it includes 4.5 and it includes infinity. So anything with this choice, answer choice 2.